مرحبا بكم في هذا الجزء العاشر من المحور الثاني لمادة نظرية الآلات Theory of Machines. We will take here some examples. First example, we have L equal 3, number of links. First one is the ground, second one and third one. J1 equal 3 also. It is the number of joints having 1 degree of freedom. First one, second one, then third one. And here we haven't a higher pair. So J2 equals 0. M, by using this formula, is equal 0. So motion for this mechanism is impossible. Mechanism forms a structure. For the second example, it is called 4-bar mechanism. We have number of links equal 4, the ground, second, third, and fourth. Lower pairs, rotation here, 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 and here, 4, and no higher pairs. So M equal 1, mechanism can be driven by a single input motion, constrained mechanism. So it can be controlled by the rotation, here or here. Third example, it is slider crank mechanism. So number of links is equal 4, ground, second one, connecting rod, the crank, third one, and the slider, number 4. So here, M is equal 1. 2 is the crank, third is the correct connecting rod. So J1 equal 4, rotation, rotation, here, and here also rotation, and sliding here. No higher pair, so M equal 1, mechanism can be driven by a single input motion, constrained mechanism. So the single input can be a rotation. Let me clean here. It can be the rotation here or the translation for the slider. Fourth example, number of links is equal 5 include the ground. Lower pairs, we have 5 rotational joints, and no higher pairs. So M is equal 2. This mechanism requires 2 input motions. That means there must be 2 controlled joints to produce constrained mechanism. To check, M is equal 3 into L minus 1 minus 2J1 minus 0. So it is equal to. Number 5, we have 4 links include the ground. First one, second, third, and fourth. Lower pairs, 5, rotation here, rotation here, rotation here, 3, rotation here, 4. This rotation in A, here, if we explain, between 2 and 4, we have 1 rotation. Between 4 and 3, we have 1 other rotation. So in total, we have 5. 2, 3, 4, and 5. Higher pair is 0. So M is equal minus 1. Mechanism is over-constrained, statically indeterminate structure. Example number 6. We have a gear joint here. We assume sliding. There is rolling and sliding between teeth. So number of links or solids is equal 3. So the gear number 1, number 2, so the first one is the ground. Number 2 and number 3 are the gears. So we have 2 lower pair joints. First one is the rotation here, and second one is rotation here. So between teeth, and this region between teeth, we have 1 higher pair. So M is equal 1. Mechanism can be driven by a single input motion, constrained mechanism. Number 7, we have 7 links. Number of lower pair joints is equal 8. and no higher pair joints. So M is equal to 2. Number 8, we have to assume here no sliping in this region. So number of links is equal to 4, include the ground, 1, 2, 3, and 4. Lower pair joints, we have 4. Rotation here, rotation here, and rotation here, 3. And in this region, we have rolling without sliding, so 1 degree of freedom joint, total is 4. And no higher pair joints. So M mobility is equal 1. Mechanism can be driven by single input motion constrained mechanism.